Hi everybody! Today we are covering converting repeating decimals and fractions. Before we begin, just reminding you that you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem we cover. Also remember that you can pause to jot down important notes. You can rewind to view information again. And you can fast forward if you think you got it, but just be careful. Be sure that you don't miss out on anything important. So first we're going to cover how to change a fraction into a decimal. There are two different methods. The first method, which you probably already know of, is that you're going to get your fraction to a denominator of 10. So if we start off with the example 4/5, we would see that the denominator is at 5. 5 would need to multiply by 2 in order to get to a denominator of 10. The numerator also needs to multiply by 2 because you want to keep the fraction equivalent. So 4 times 2 on top, 5 times 2 on the bottom, and you get 8/10, or 8/10. By knowing what the fraction should be called, that'll help you transfer it into a decimal. Since it is 8/10, then it will become 0.8 because you put the 8 in the tenths place. And that's why it's important to get it to a denominator of 10 or 100 or thousandths, because your decimals will always have tenths, hundredths, or thousandths when you say it out loud. So then it's important that you remember the names of your decimal places. If you don't know what it's called, tenths, hundredths, or thousandths, then it'll be really hard for you to change it into a decimal. So remember that they have to match the number of zeros. For instance, tenths is only one decimal place over to the right of the decimal point because a 10 has only one zero. Hundredths are two decimal places over because 100 has two zeros. Thousandths is three decimal places over because 1,000 has three zeros. So that should help you remember the names. So that's one method of how to change a fraction into a decimal. The key is to get to a denominator of 10, 100, or 1,000. And multiply the top and bottom by the same number. The other method is to just divide the numerator by the denominator. So if we take the example of 4/5, or 4/5 again, then all we have to do is take the top number, the numerator, and divide that by the bottom number, the denominator. So 4 divided by 5. In your calculator, you'll see that that's 0.8 or 8/10, just like our answer above. So let's take a look at our calculator just to double check that. So we would take 4 divided by 5, and that'll give us 0.8 or 8/10. That's a little quicker. I recommend it that way, but just know that there are two different methods depending on what you prefer. And here the order does matter. So if I were to switch 5 divided by 4 now, that will not give me the correct answer. It'll give me 1.25 or 1 25 hundredths or 1 1/4. And that's not correct because your numerator is smaller than your denominator, so it should not be a mixed number. It should be a number less than 1 because 4/5 is less than 1 whole. So the order really does matter on that method. So that's how you change a fraction to a decimal, two different methods. Now moving on to how to change a decimal into a fraction. There are also two different methods here. The first method is you simply read the decimal because remember it's the reverse of this method up here. So you're going backwards. If you have 0.8, then you're going to read it as 8/10, and then that's going to help you set up the fraction. And then instead of multiplying top and bottom by the same number, you're going to divide to get it back to its original form and reduce it. So here we have 0.42, or if we want to read it in proper terms, we see that 42, the two digits are 2 spots or 2 decimal places away from the decimal point. So since it's 2 spots, that's like 100. So it's 42 hundredths. If I were to change 42 hundredths into a fraction, I would see that since it has 100 in it, that means it's 42 over 100. But remember, I need to reduce it down to its original form. So since 42 and 100 are even numbers, I can divide top and bottom both by 2. And then I'll get to 21 over 50, or 21/50ths. So it's really just the reverse of this top method up here. You're just doing the opposite operations in reverse order. So it's very important for you to understand how to read that decimal and to reduce it. The second method is really good when you have patterned repetition. So that's when the decimal repeats itself over and over and over again in a pattern. So this method wants you to get rid of the pattern repetition, and you're going to use algebra for this one. So this method is very useful. However, it has a lot more steps. So for example, we're going to use the decimal 0.36 repeating, or 0.363636, like repeating on forever. Here, I wouldn't say it's 36 100ths. Without that bar over it, it would mean that it's not repeating, and it would be 36 over 100. But if you notice, if I put 36 divided by 100, it's not a repeating digit. Here, or repeating digits. Here, the 36 repeats again and again. 36 over 100 is not repeating, so be careful with that. That bar really matters over the 36. So here it's important for you to understand that 0.36 repeating means that it's going on and on and on forever, and that it has 2 repeating digits. That's going to come in handy later. So first step, we're going to set 1x equal to 0.36 repeating. And I just wrote it twice and then just put the dots afterwards. That'll suffice. Remember, since this method has a lot of steps, you might want to pause, rewind, and all that. My second step is to set up 100x equals to 36.363636 repeating. So this part is really important. You're setting it equal to 100x because you're essentially moving this decimal point that was originally in front of the repetition 2 steps back. Okay, so now that it's behind 36, so we moved it 2 steps back, and the reason why we moved it 2 steps back was because we want to still keep the decimals repeating. So if we only moved it 1 step back, then it would have 636363 on the top, but 363636 on the bottom. So we wanted to move it over 2 steps so that in the back of the decimal point is still 363636. And since we moved it back 2 steps, remember there's 2 decimal places, so then we would set this one 100x. So this is 100x equals 36.363636. If we only moved it 1 place over, then it would be 10x with only 1 0. Okay? So we have 100x for the 2 decimal places we moved it over, and then we have 36 in the front now since we moved it over twice, and we still have the 36 in the back. So we wanted to match up the digits behind the decimal point. The reason why we want to do that is because later on we're going to take our 1x and our 100x, and we're going to set them up so that we subtract the smaller x away from the bigger x. So now we have 100x equals 36.363636. This is after we moved it, minus, or subtracting, 1x equals 0.363636. So just like in normal subtraction, whatever is repeating on top and bottom gets eliminated. That's the whole point of this method. We don't want that repetition. So how do we eliminate it? We match them up, and then we can subtract them away, because 6 minus 6 is 0, 3 minus 3 is 0, 6 minus 6 is 0, 3 minus 3 is 0, 6 minus 6 is 0, 3 minus 3 is 0. So all those match up and they get eliminated. They become basically 0. Then 36 subtracting 0 is 36. Move the equal sign down. 100x minus 1x leaves you with 99x's. So just like that, we eliminate the repeating digits. But what we had to do is we had to set up another x with the repeating digits. So now we're here, we have 99x equals 36. So here's where the algebra continues. You're going to solve for x by dividing by the coefficient. I have to get x by itself. So in order to get x by itself, I have to get rid of this 99. This 99 is being multiplied by x. So the opposite of multiplying by x is to divide, right? Instead of 99 times x, it's going to be divided by 99. And whatever I perform on one side of the equation, I have to perform on the other side. So these two 99s eliminate. They cancel each other out because 99 divided by 99 is 1. So we get rid of the 99s. So then we just have x equals 36 divided by 99. And that's how we get our fraction. We get 36 99ths. But you still have to reduce the fraction if you can at the end. These both have 6 and 9 at the end, which means that it's divisible by 3, because 3 goes into 6 and 9. So I'm going to divide by 3. I get 12 over 33. I notice that it can be divisible again by 3, so then that's how I divide by 3 again, top and bottom, and I get 4 11ths. Or you could have just divided from the very beginning by 9. 36 divided by 9, is that 4 already? And then 99 divided by 9, is that 11? Okay? It doesn't matter how many times it takes for you to reduce it to its final fraction. So that's the answer, 4 11ths. If I check it, 4 divided by 11 should get me back to the decimal. So let's check it. 4 divided by 11 is our number right there. 0.3636363636, all the way till forever. The only reason why this calculator has a 4 at the end is because it couldn't fit the extra 6, so it rounded it up to a 4 because it's trying to let you know what's going on by rounding, okay? So don't let this 4 fool you. It still goes on 363636. It just can't fit it anymore, so it rounded it, okay? You might want to rewatch that last method over again because that is the trickiest method. But for the rest of this video now, I'm just going to go through some examples so that you are familiar with the problems you have to complete. For this problem right here, you are being asked to select the decimal that is equivalent to 27 30-seconds. So there's only one answer. Pause the video and see if you can figure it out on your own. Okay. If I were you, I probably would have chosen the second method that we went over, which is just dividing the numerator by the denominator. 32 looks like it would be pretty tough to get to a denominator of 10, 100, or 1,000. So the second method would be easiest. 27 divided by 32 is this number right here, 0.84375. Okay, it looks like it's this answer right here. D could also be the answer, however, it has a bar over 375. That would mean that it doesn't end. This number ends on the calculator. D would be 0.84, and then the 375 is repeating over and over again. But that number was not, so it's got to be C. Okay? So that's one type of problem that you could work on. Okay, so this problem now tells us to rewrite a repeating decimal as a fraction, a simplified fraction. So remember, you have to reduce at the end. Go ahead and pause this video, see if you can do it on your own first. All right, so what I notice about this problem is that the 5 is not underneath the bar. So the 5 is not repeating. So if I were to set x equal to the repeating decimal, it would look something like this, right? And keep in mind, back to the steps, that we want all the repeating digits to come after the decimal point because we want it to be eliminated and we want to be left with a clean whole number. So let's fix this first. We're actually not just going to leave it like this, right? So in my mind, I'm thinking, okay, I need to get rid of this 5. So I'm going to move this decimal place over one spot so that the decimal place now is behind the 5 and I just have the 1s repeating. I want the repeating stuff behind the decimal point. Since I'm moving it over one spot, this is going to become a 10x, okay? Because a 10 has one decimal place, just to match up the other decimal place. So one of my x's is going to be 10x. 10x equals, this pen is going haywire right now. $10x, we moved it over one spot, so the 5 is in the front now, and the 1s are now in the back, all repeating, okay? So let's see, we have a 10x equals 5.1111. We have to create another one where it's just the 1s in the back. So let's use a different color. Let's see, if we move it over 2 spots now, it would become 5 and 1 in the front and all the 1s still in the back, okay? But since now we move it over 2 spots, it's going to become 100x, okay? So we're just messing around so that the 1s are still the only ones in the back. We can move it over as many times as we want. We moved it over once to get the 5 just in the front, so that was 10x. We move it over twice, now we have 51 in the front, and it's 100x. That 100x is going to go above when we subtract, and now it's 51.111111. When we subtract that, all these ones cancel out, and they're gone. We wanted that. 51 minus 4 will now be, let's see, 46. Okay, so we got that whole number. We like that. 100x minus 10x will be 90x. Okay, so that's how we got to that next step. And then we have to reduce. This is 90 times x, so the opposite would be to divide by 90, both sides. Those cancel out, so now x equals 46/90ths. They want us to reduce this. They're both even, so let's try dividing by 2. 46 divided by 2 is 32. You can use a calculator. That's 45. And I think that's as much as we can reduce it. Let's see. Yeah, I think so. So this should be 32/45. Let's see, did we reduce it correctly? Oh, you know what I should have done? I should have checked it in my calculator before I submitted it. That's a good idea, right? Okay. Let my lesson be your lesson. Ooh, see? When I put that in, it didn't work. So I probably did something wrong. It was 0.51111. I got 0.711. I mean, that's close, but it's not the same. So let's try and see what we did wrong. Or I did wrong. We moved it over once to get 5.111. That was 10x. We moved it over twice now to get 51, and that was 100x. So now we subtract. Let's see, is 51 minus 5 equal to 46? 51 minus 5, that is 46, okay. Now 100 minus 10 is 90. 46 divided by 90 Did I divide these correctly? 32. Oh, that's what it was. Oof, that was a silly mistake. I hope you caught it at home. 46 divided by 2 is not 32. That's what happens when I don't use a calculator. It's 23. I flipped the numbers. Now let's see if that works. 23 divided by 45. Oh my gosh, what a silly mistake. Okay. Well, I definitely feel like that was not deserved, but let that be a lesson to you to check your work at home. There we go. Okay. All right. So let me know if you have questions when you're working on this at home. Be sure to rewatch that video again and again because this one is tricky. There's so many steps. And if not, then I will see you in class.